We hear the word environment everywhere, in politics, corporate boardrooms, and daily news. Yet, despite its universal use, it remains one of the most systematically misunderstood concepts in modern public discourse. The term derives from the French environner, literally translating to encircle or surround. At its root, it describes drawing a boundary around an organism. When most people hear the word, they picture a static backdrop of pristine nature, forests, oceans, or open fields. Treating the environment merely as scenery ignores how the system actually functions. A rigorous academic standard, such as the definition codified in the 1986 Environment Protection Act, shatters that simple boundary. The environment is the sum total of water, air, land, their complex interrelationships, and human beings themselves. To solve global ecological crises, we have to stop viewing the natural world as a passive stage for human activity. We must map it as a multi-segmented, integrated architecture governed by strict physical limits. That architecture begins with 4 physical spheres. First, the atmosphere. With 99% of its mass within 32 kilometers, it filters UV radiation below 300 nanometers. Below is the hydrosphere, where only 1% is available fresh water. Next, the solid lithosphere. Intersecting them all is the biosphere. These 4 segments are not infinite reservoirs. They provide mathematical boundaries that dictate exactly how much biological and human life the planet can support. This physical base does not exist in a vacuum. It is continuously altered by 3 interacting modifiers: physical, biological, and cultural elements. Because of this constant interaction, we classify environments entirely by the degree of human interference, from purely natural systems untouched by man, down to semi-synthetic systems like managed lakes, all the way to fully artificial environments like cities and agricultural grids. Kurt Lewin established that humans operate within 3 overlapping environments. The physical environment dictates our efficiency, the social environment determines if our society is conducive to development. Finally, the psychological environment, or life space, dictates our personal goals and reactions to external barriers. These individual psychological adjustments scale up into collective cultural behavior. When millions bypass environmental barriers to meet basic needs, this aggregate of human drives becomes the primary force reshaping the global physical spheres. The tension between human expansion and planetary limits becomes visible when we move from theoretical models to the raw math of consumption. The primary variable stressing the system is explosive population growth. Adding over 17 million people annually places compounding pressure directly onto all 4 physical spheres. This visual maps India as a mathematical extreme of this systemic stress. You have roughly 16% of the entire global population attempting to sustain itself on just 2.4% of the world's land area. Look at this image showing the direct consequence on the lithosphere. The immense demand for agricultural output leads to extreme soil degradation. Water and wind erosion alone have caused the degradation of almost 150 million hectares of land. This grazing herd illustrates another vector of physical exhaustion. Supporting hundreds of millions of livestock on a fraction of the necessary pasture land accelerates the destruction of vegetative cover, turning fertile areas into scrublands. This triggers secondary failures in the hydrosphere. As unplanned urbanization accelerates, community wastes, chemical fertilizers, and industrial effluents overwhelm that highly limited 1% of available freshwater, causing acute surface and groundwater pollution. We are left with a fatal feedback loop. Rapid population growth drives intense poverty, and impoverished populations are forced to degrade the immediate natural resources of their environment just to survive, pushing the entire integrated architecture toward collapse. If we know exactly how the mechanics of this collapse work, why have our traditional scientific methods failed to stop it? This diagram illustrates the hierarchy of research approaches. At the far left, an intradisciplinary study involves working strictly within a single, isolated discipline. This framework is mathematically insufficient for addressing an environment where a change in the soil immediately triggers a failure in the atmosphere. The evolutionary steps of problem solving lead to multidisciplinary and cross-disciplinary models. These allow researchers to draw on different fields or view one discipline directly from the perspective of another. Further right, interdisciplinary work represents a deeper integration, actively synthesizing the knowledge and methods from different sciences into a single, cohesive approach. The ultimate requirement for solving ecological collapse is a transdisciplinary framework. This creates a unified intellectual model that exists entirely beyond isolated disciplinary perspectives. Solving these systemic failures requires a unified intellectual framework entirely beyond the limits of isolated fields, a transdisciplinary mandate for a new architecture of human thought. To put this transdisciplinary framework into practice, specific applied academic disciplines map onto the problem to form actionable, real-world solutions. Environmental science serves as the diagnostic arm. It is the rigorous scientific study of the physical systems, air, water, soil, and land, and the exact quantified damages incurred by human interaction. Environmental engineering operates as the operational arm. This discipline focuses on the technical, physical processes required to protect the environment and actively improve the health of human populations. Environmental management is the strategic arm. It handles the restructuring of corporate and enterprise objectives, shifting the economic approach from forcing expensive, reactive cleanups at the end of a product's life cycle to planned, sustainable investments right at the start of the production chain. Ultimately, these applied fields must adhere to holistic principles, like those recognized by the ecologist R. Misra. The absolute rule of ecology is that all human actions, resource processing and withdrawals, must be perfectly synchronized with natural ecological cycles. Our ongoing survival depends on recognizing the complete hierarchy of this architecture, from the psychological environment of a single individual all the way up to the global biosphere. We have to strictly manage our development and our economies entirely within those unyielding planetary limits.